GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A wheel has angular acceleration of 3 radians per second square and an initial angular speed 2 radians per second. In a time of 2 seconds, it has rotated through an angle of. That means indirectly it is asking angular displacement. It is in radians. Okay. For that, look at the data given. Angular acceleration. Angular acceleration is given. Let that is alpha equal to 3 radians per second square. And initial angular speed, let that is omega naught equal to 2 radians per second. In a time period, let it be t equal to 2 seconds. It has rotated through angular displacement. What is the angular displacement? Let that angular displacement is theta. What is the value of theta? That's what he's asking. Okay, for that, let us take the equation of motion for linear motion first. For a linear motion, for a linear motion, equation of motion is no displacement s equal to ut plus half a t square. Okay, the same formula for angular motion. For angular motion, in the place of s, write the angular displacement omega naught t plus half into where a is the linear acceleration. In the place of linear acceleration, write the angular acceleration times the t square. It is equal to omega naught. Look at the omega naught given 3. 3 into time period given 10. Time period is 2 seconds only. Time period is given 2 seconds only. And initial angular acceleration, angular velocity to make 2. 2 you should be very careful. Here this omega naught is given to 2. Time period also given to plus half into angular acceleration is given 3 into 2 square. Angular acceleration is given 3. Okay. Now simplify it. It is 4 plus here it is half into 3 into 2 into 2. Here 1 2 is cancelled. 4 plus 3 into 2 6 equal to 10 radians. That is the angular displacement. Look at the options. 10 radians. Option A is absolutely correct. Understood clearly? Very simple problem. Okay. Similarly, let us take the another important problem. It is asking like this. A car runs at a constant speed on a circular track of radius 100 meters, taking 62.8 seconds for every circular lap. It is given radius of circular track, radius of circular track, Kepler equal to how much it is given 100 meters. Okay, and time taken, let that is t 62.8 seconds. The average velocity and average speed, you know, average speed v average, 1 minute, average speed equal to total distance traveled, total distance traveled divided by total time taken. Total time taken. For a circular motion, total distance traveled equal to what? 2 into pi into r divided by time taken t. It is equal to 2 into pi value 3.14 into r value 100 divided by 62.8. 62.8. So let us take another slide. Here it is average speed. Average speed. It is 2 into 3.14 into 100 divided by 62.8. Simplified. Let 2 into 3.14 equal to 6.28 into 100 divided by 62.8 is equal to 628 divided by 62.8 is equal to 10 meters per second. That is the average speed. Now, what is the angle average? What is the average velocity? Average velocity equal to total displacement. Total displacement divided by total time taken. Total displacement for a circular motion, it starts with a particular point and again it is coming back to original state of completion of one circle. So total displacement is 0 divided by time 100. 0 by right, 0, time is 62.8. 62.8. 0 by something 0. It is in meter per second. So the 10 and 0 is the correct answer. Look at the options. He is asking average velocity. Average velocity is 0 and average speed is 10. 0 and 10. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. For angles of projection of projectile at an angle 45 degrees minus theta and 45 degrees plus theta, the horizontal range described by the projectile are in the ratio of. It is given for two projections. For projection 1, angle is given, let it be theta 1, 45 degrees minus theta. And for projection 2, for projection 2, given angle of projection theta 2 equal to 45 plus 45 degrees plus theta. The horizontal range described. Let H1 be the horizontal range with projectile 1. H2 be the horizontal range for the projectile 2. Horizontal range. What is the horizontal range? Horizontal range equal to u square sine 2 theta by g. Then what is H1? H1 equal to u square sine 2 theta 1 divided by g. Similarly, H2 equal to u square sine 2 theta 2 divided by g. Now let us substitute the values. H1 equal to u square by g into sine 2 into theta 1 45 degrees minus theta. Similarly H2 is equal to u square by g sine 2 into 45 degrees plus theta. Okay, it is equal to H1 equal to u square by g sine 90 minus theta, whereas other one is sine 90 plus theta, u square by g into sine 90 plus theta. Let us take another slide. H1 you got u square by g into sine 90 minus theta, whereas H2 is u square by g into sine 90 plus theta. Okay. You know sine 90 minus theta equal to cos theta. It is u square by g into cos theta. Similarly, H2 also equal to u square by g into sine 90 plus theta also cos theta. Then what is the H1 divided by H2? H1 is u square by g cos theta divided by u square by g cos theta. Since both are same quantities, it is 1. Therefore, H1 is to H2 is equal to 1 is to 1. That is the answer. Look at the options. Option B is absolutely correct. Understood clearly? It is very, very important problem. I can say 5-star problem. Means this kind of problem can be repeated. Okay?
GeopByte.